Hi everyone, my name is Muhammad bin Azman.
My name is Muhammad Azman.
Okay, for this video, we're going to do for lab task number 2, which is for my part is for my part we are going for my part I'm doing adding the switch which is already built in on the Nuvoton board for the 4 LED to blink in sequence. And one more is to build a circuit for external switch to control the RGB LED.
Okay, and for the second task, I'm going to do a scan key keypad, which can trigger a 7-segment display to display number from 0 to number 9. And once we press, for example, once we press number 0, the scan key will read the number 0 and assign a suitable time delay for that, which is actually fast. And then up to number 9, the scan key will assign a delay for a longer delay for the 7 segment to count up to 9.
Okay, so let's get going. Okay, so first, this is the coding for blinking up for LED and RGB LED using switch and external switch. So first, we need to include all the library that we are going to use, and then we're going to declare the variable for the switch, which is this one. State is for the GPB 15 and E state is for GPE 0. We are going to use these two switch at the GPB pin 15 and also GPE pin 0. So this is the callback function for GPIO-AB, and this also the callback function for GPIO-CDE. So first we need to initialize all the LED that we are going to use, which is the first 4 is for the 4 LED, and the last 3 is for the RGB LED. So first we're going to the main function. So first we need to unlock the register and set the system clock to run at 50 megahertz, and then we need to lock back the register, and then we need to call back the init underscore LED function so that we can initialize the LED. And we're going to go to the while loop. This while loop will forever loop what is inside the loop. So first we will display the 4 LED and the RGB LED in to turn on. So it will keep turning on until we press the switch on the Nuvoton board. So this one we open the eGPB pin 15 to get the input, and also we enable in 1 for the eGPB pin 15. So it will execute this blink function. It will call this blink function. The blink function, what will the blink function do is it will control the 4 LED blink. So while 1, the state will get bit from the eGPB 15. For if the GB 15 is 0, which is the button is pressed, so it will close all the 4 LED by sequence, which is we put delay between the LED, and then if we release the button, it will go back to high. And then we set the debounce time 11 and also the enable debounce time for eGPB 15. And then for RGB LED, we open the pin eGPE 0 to get the input, and we enable in for the eGPE 0 to get the input. We enable the eGPE 0. So this is the function that we are going to use for the blinking the RGB LED. This will be called back at the last in the main function. So while 1, E state is for the eGPE 0. We get bit from the switch eGPE 0. If the eGPE 0 is pressed, all the RGB LED will turn off in sequence by referring to the delay, and if the pin switch is released, it will turn on the RGB LED again, and then we call back the set in callback function at the last main, and it will continue to loop in the while loop. So this is the result of using switch to control the 4 LED by sequence. So as you can see, if we did not press this one is the switch button for the 4 LED. If we did not press it, it will stay on, but if we press, so it will go to, it will off, and until we release the switch, it will remain off. So if we release the switch, it will go back on. This is the output for RGB LED using switch. So as you can see, this is the circuit for the switch. We use the pin GPE 0, and another one connect to the ground at the Nuvoton board. So as you can see, if we did not press the button here, the RGB will still on. So if you press it, it will turn off in a sequence, and when we release the switch, the RGB LED will be turned on back.
Okay, now I am going to explain the coding for the second task in the task 2. First of all, we are going to include all this necessary file that we are going to use. For example, the scan key and the 7 segment. And after that, I'm going to do the loop for the delay, like kind of system delays, but it's not really dependent on the drive system. Then we are going to initialize the output input for the keypad. So we open the GPIO, use the GPIO open, and then we are going to scan the keypad. So this is the setting, this is the function code to setting up the scan key to read the keypad. So that we are going to do another function to display each of the necessary numbers with the delay. So what we are going to use is that we are going to use the implementation of separate function for each keypad. So for example, the segment display 1 will be run if the user select the 1, and then the delay will be minimal, which is about 0.5 second, and then if the user select keypad number 2, then the button will delay about 1 second for each interval of the number, and so on until the number 9. So theoretically, based on this coding, the number 9 7 segment display will have the longest display, and inside the main program, we use the unlock register to set the drive to set the clock, and then we lock back the register, and then open the keypad, and then we can use a while one to ensure that the program run continuously. Then assign the number that we scan through keypad into a variable named number, and then we just use a selection if to actually check the value inside the variable number. And after that, there are another loop inside the selection number, and then and this will count the number from 0 to 9, and the 7 segment display will also show the number 0 to 9, and after that it will go on until it close the 7 segment. Okay, now I will show you the output of the 7 segment, in which you can increase the interval by pressing the keypad. So when we pressing the keypad, 3 the interval will be faster and 2 will be faster, but we have to reset the button board before we are pressing each number. So for example, if we are pressing number 9, as you can see here, the interval will show, the interval between the numbers is lower than compared to the interval that set for number 0 and 1.